All right, in this next video, we are going to talk about the pH of salt solutions, right? We are used to seeing acids and bases as neutral compounds, but remember, conjugates of neutral acids or neutral bases are still acidic or basic. So this means we can make salts, thus ionic compounds, that contain an acid and or base, and thus we can have salts that when put in water, the pH will not equal 7. Okay? So let's talk about the scenario where that occurs. So for any salt, you're going to have the cation and you're going to have the anion for the salt, right? We've got our cation and we've got our anion. And here's the question we're going to ask. Will our cation, okay, so we'll call our cation M plus, will it react and protonate water to form H3O plus? Okay, so we're always going to ask, is the cation an acid specifically? An acid. Is the cation an acid? Can it donate a proton? So here, let's look at it. Let's look at it as HA plus instead. That's probably a better way to write it. So HA plus, and thus we would get just a neutral A as the conjugate base and H3O plus. So what cations are acidic? So acidic cations are ammonium derivatives. These are acidic cations. These will lead to a solution with a pH less than 7. Okay? For our purposes, any other cations will have no effect and thus will not react with water, and the pH will be 7, whatever it would naturally be. Okay, so that's kind of our assessment. Okay, so we ask, is the cation acidic? Can it donate a proton? So examples of cations that are not going to have an effect: sodium, potassium, right? They're not even Bronsted-Lowry acids because they don't have a covalently bound hydrogen. So now, are there ways to have metal cations that can be acidic? Yes. So there are acidic some. So let me add to this list. Some transition metal cations are acidic, but we tend to avoid those situations. So acidic cations, let me put that over there. Okay, so there are some transition metal ions, but when you put them in water, a water molecule will stick to the cation and then an H plus will pop off. Now, on the other side of things, B minus, let's say, we're going to ask, is the anion a Bronsted-Lowry base, right? So we could have our B minus aqueous plus water, and it could react to form HB and of course OH minus, right? If we form H3O plus, that's what results in a pH less than 7. If we don't, that's why it would be pH 7. So basic anions versus other anions. So what's going to result in a basic anion? Anything that is the conjugate of a weak acid. So for example, CN minus, because its acid form is HCN. Or acetic acid, so acetate, C2H3O2 minus, and its acid form is HC2H3O2. These are both weak acids, okay? So so they will lead to, by the way, a pH greater than 7. So what leads to pH equal to 7? Strong, so the conjugates of a strong acid will have no effect on pH. So what do we mean there? Well, Cl minus or NO3 minus, right? Cl minus is the conjugate base of HCl, and NO3 minus is the conjugate base of HNO3, and these are both strong acids. And remember, strong acids undergo approximately 100% ionization, and that means that these are effectively 0% ionization, and thus do not affect the pH. Okay, so here is the thing to remember for these, okay? You look at the cation. If it is an ammonium-based cation, the pH, that cation is going to make the pH of this solution less than 7 because that cation will independently react with water, okay, to reform its base form. Okay. On the other hand, for anions, and by the way, this is a very short list. The following anions give you a pH of 7. Cl minus, Br minus, I minus, NO3 minus, HSO4 minus. Okay? This is the list that you should memorize here of anions that lead to a pH 7. Any other anion, effectively all other anions. So let me change the way that this. Let me write it as neutral. They're not neutral because they're anions, but meaning making a neutral solution anions. Those are going to be chloride, bromide, iodide, nitrate, and HSO4, hydrogen sulfate. All other anions will lead to a pH greater than 7 and thus a basic solution. Okay, so let's look at a handful of examples. Okay, let's look at KCl. Okay, so our first question is K plus acidic? No. And so it will not affect the pH. Okay, can't even donate a proton. Cl minus, is it going to be basic? Well, if you remember, it comes from the strong acid HCl, and thus no, it will not react with water to reform HCl. So pH will be equal to 7. Thus, the pH of a potassium chloride solution should just be 7. Okay, let's look at another one. Let's look at something called sodium benzoate. I'm going to write it in a weird way, so don't freak out. C6H5COONA. So, because of the way this is written, the cation ends up on the right side. This is a rare example, but don't let things like this trick you, right? So that means this would be C6H5COO minus. Will this be basic? And then over here, Na plus, will this be acidic? Because again, we just look at the cation, right? Cation, anion. Cation, anion. So, in the case of sodium, sodium is not going to donate a proton to water. It's not a Bronsted-Lowry acid. And thus, if it's not a Bronsted-Lowry acid, it's just going to leave a pH 7 solution. Now, C6H5COO minus, okay, remember our list. Cl minus, Br minus, I minus, NO3 minus, and HSO4 minus will all lead to no effect, right? So pH equal to 7. However, this anion is not on that list. So yes, it will strip a proton off a water molecule to leave behind OH minus, thus resulting in a pH greater than 7 for this solution, and thus a basic solution. Okay, let's look at one more example. CH3NH3Br. Okay, methyl ammonium bromide. You don't need to worry about that though. So here is our cation, and here is our anion. So our anion is Br minus. Our cation is CH3NH2. Sorry, NH3. That should be a 3 as well. Plus. Okay. So again, acidic, basic. We'll start with the anion this time. Is this the conjugate base of a strong acid? Right? So in other words, is it on our short list? Yes. So that means it will have no effect. It's not going to result in a basic solution. This ion is going to do nothing with water. Now, on the other side, is this acidic? Well, remember, ammonium cations and some transition metals, but don't worry about the transition metals. But ammonium cations, which is what this is, right? This is of the RNH3 plus variety. Answer yes to this question. And so the pH will be less than 7 for this solution. And thus, this compound will generate an acidic solution. All right. So that concludes the pH of salt solutions.